All right, good morning, everybody. Let's go ahead and get started. We're here to talk about achieving PCI compliance with MySQL. My name is Ryan Lowe, and my co-presenter, Fernando, he's down there. If you want to ask him any questions afterwards, feel free.
All right.
Our agenda today is we're going to go over an overview of what PCI is, the 12 requirements and sub-requirements and some sub-requirements, which requirements apply to us specifically as MySQL DBAs. So I guess, can I get a show of hands? Who is a MySQL and not familiar with PCI? Who's a PCI expert and not familiar with MySQL? And who's a manager that doesn't do either? All right, so for the managers, just let me tell you, PCI is tedious, expensive, and it takes a long time. Your IT guys are going to ask you for money. Give it to them so that you can accomplish your goals. And then we'll go through a requirement by requirement discussion on how we can meet the PCI requirement in question through MySQL and surrounding MySQL. And then we'll go ahead and take questions. You can feel free to interrupt me at any time if you need to ask a question or tell a story or just make a comment. PCI DSS was originally 5 separate companies handling their own compliance. Visa, MasterCard, American Express, JCB, and Discover all had their own programs that anybody who wanted to process their card had to follow. In 2004, they came together to form the PCI Security Council. And the reason behind that was twofold. Number one was to eliminate the costs of redundancy for each one of them having to maintain their own programs. And the other one, and arguably more important, was to offset some of the costs of credit card fraud. Traditionally, these costs were paid by the card companies themselves, and it's quite expensive when somebody has to go through identity fraud or credit card fraud. So what they want to do is offload some of these costs to the card processors. And if you suffer a data breach and credit card fraud is committed and you are found to be non-compliant at the time of the breach, you have to pay fines. And these fines can be tens of thousands of dollars, hundreds of thousands of dollars, or more. You also have to pay an undisclosed amount of fees. And the fees are widely speculated to be significantly more expensive than the fines. In a worst case scenario, if you don't pay your fees, they can take away your ability to process credit cards, which for a web-based business that only takes credit cards can be a real killer. There are a lot of myths and common misunderstandings associated with PCI, and the PCI Standards Council publishes a top 10 list. I'm not going to go through all of them here because we'll probably be pressed for time, but there are a couple that I think you need to know. The number one myth is that to consolidate efforts and myth number one is that one vendor and product can make you compliant. If you're in the PCI market, you're going to see a lot of these network compliances that have this checklist of how they address each one of the 12 requirements, and that's just not true. They may address part of each requirement, but one product is not going to make your organization compliant. It's not a one-time event. It's not like you become compliant and then you're done. It's an ongoing process, and you can be compliant one day and then not in compliance the next. And
just so everyone's on the same page, what does PCI DSS stand for?
Payment Card Industry Data Security Standard. Thanks, Daniel. And the second myth I want to that they mention is outsourcing card process can make you compliant. And this is an important myth because if you outsource incorrectly, then that's true. You still have to become PCI compliant yourself. But if you outsource well, i.e., none of the credit card information goes over your network or is stored on your network, then you can totally offload the cost of PCI onto somebody else. And this is really important. If you're not already having to do PCI compliance and you're just thinking about it, ask yourself, do I absolutely, positively have to process and store credit cards on my network? Probably not. It's a very expensive proposition. My example is, okay, I'm making widgets, this is my company, it's my first year, I'm going to start selling things next month. My forecast for the year is that I'm going to sell 10,000 widgets at a price of, let's say, $10 each, right? So at the end of the year, that gives us $100,000. People say, oh, well, if I process my own credit cards, then I only have to pay 3% to the companies instead of 5% that I'd have to pay somebody else to process. Well, if you do the absolute math, that's only a savings of $2,000. Your PCI efforts are going to be way more expensive than $2,000 a year. So, it's a financial trade-off. until you're a very big company, you're probably not going to want to invest in PCI compliance. There are actually 4 levels of merchant responsibility. If you process even one credit card over the course of a year, you're a level 4 merchant. And most of us in this room are level 4 merchants, and that's less than 20,000 transactions per year. And levels 3 and 4 are 99.99% of merchants. It's only levels 2 and 1 that, the Walmarts, Sears, Amazons of the world, and it gets progressively more expensive because there are more stringent requirements for levels 1 and 2 than there are for 3 and 4. And I typically recommend that if you're a level 3 or a level 4 merchant, have somebody else do your payment card processing. Invest that money that you save instead of doing PCI. Make your application better. Make your product better. Do more marketing. Get a bigger user base. There are different levels of requirements for each of these. Level 4, you're required to do a quarterly network scan by a qualified security vendor, and you're also recommended to do an annual self-assessment. An annual self-assessment is just a questionnaire that you have to fill out, and although it's only recommended, I strongly encourage you to, even as a level 4 merchant, go ahead and do that, because the only difference between a level 3 and a level 4 is that you're now required to do the annual self-assessment. It's at least good practice, even if you don't formally submit it and turn it in, you at least go through the efforts so that you know what it's like. A level 2 merchant and a level 1 merchant, there's additional stuff, but if you're a level 1 or 2 merchant, you probably shouldn't be here because you should be an expert at PCI. PCI DSS is currently in version 1.2. It's widely believed that there's going to be another release and update later in the year, but each version is built on top of the last, so it's not going to change your efforts that you put into 1.2 compliance should apply to the next version. It's divided into 6 major sections. Build and maintain a secure network, protect cardholder data, maintain a vulnerability management program, etc. If you're familiar with any security framework, whether it's SOX, COBIT, Common Criteria, HIPAA, these are all familiar to you. These are just standard security best practices that you should really be doing anyway. The best visual representation that I've seen of the 12 requirements, I stole this from some other webinar that I can't remember. If you know who it is, we give them credit. Divides it into 3 main sections: network security, data security, and physical security. Requirements 10 and 12 span all 3. That's log management and information security policies. So mostly today we're going to focus on data security, but there's certainly some overlap into network security. So let's go requirement by requirement. Requirement number 1 says we must install and maintain a firewall configuration to protect cardholder data. And I love the way that this is phrased, because everybody says, oh, have a firewall. That's great, but there's no goal, right? Everybody says just deny all policy and you're good. No, there's a specific goal of protecting your data, and it outlines what you should do to that end. Having a firewall is a great idea. You need it at your borders, you need it on your hosts, you need it everywhere. It should be possibly even an application level firewall. Although I've never had anybody come up to me and say, I'm really glad that I installed that application level firewall, it saved me. I've never had that happen. But it's not something that we can address through MySQL, so we won't talk about it today. The scope of today's talk is solely what we can do in MySQL and surrounding MySQL. But it is important to have a holistic view of security. But as database administrators, we're pretty much constrained to the database in terms of what effect we can have. Requirement number 2 says do not use vendor-supplied defaults for system passwords and other security parameters. This is pretty much a no-brainer. I remember back in my Oracle days, I could get into any Oracle database using Scott Tiger. I don't know if that's still the case, but at least Oracle 8 had that. And if you do a quick Google search for any network appliance, home wireless router, or any version of Postgres, Oracle, MySQL, you can get a version-by-version list of what the passwords are. So, I mean, this is something that's really easy to fix. Go ahead and do it, and it's also a requirement. You should be doing it anyway if you're not. And we're only going to talk about that in the context of data security, but this obviously applies to network devices, things like that. Requirement number 3 is really the core of PCI, and that is you must protect stored cardholder data. And the PCI Council has defined what strong encryption is and what algorithms it expects to use, what is and is not secure, and exactly what is cardholder data. Requirement number 4 says we have to encrypt the transmission of cardholder data across open public networks. That's 2010. I hope nobody's running MySQL on a publicly facing box. If you are, stop it. But I wanted to talk about this simply because MySQL replication is obviously a network-based solution for high availability, and it's very, very common. Although most replication instances are going to be in the same data center, most likely even the same switch, so it's not an open public network. If you have a remote data center for disaster recovery or high availability, then you're probably going to go over the public network. And I want to talk about that a little bit. The wording here is very specific, over open public networks. From 2006 to 2009, Heartland Systems, which is a payment card processor, had a data breach where there was malicious software on their internal network, and the attackers were able to sniff the traffic and gain, hundreds of thousands of credit card numbers and account information. And this was a huge breach, but at the time they were PCI compliant because it wasn't an open public network, it was internal. And one of the things that I want to impart upon you is, while you're doing PCI compliance, you're going to see opportunities to go that extra mile. And it's incrementally much cheaper to just go that extra mile than to do it separately. So end-to-end encryption is just a really good idea, and it potentially could have saved Heartland from a massive data breach. Also, when you go this extra mile for each of these requirements, that's probably going to help you in future versions. It's speculated that the next version of PCI will mandate end-to-end encryption. So go that extra mile, and then you don't have to do that much more work when the next version comes out.
I think in the case where I work, where technically we don't store credit card information, but you might say get the client or user who, say in a form or whatever, will put their credit card information, say in a text box or whatever, just being I guess. So what's a good way that you think that's not an encrypted text field, right?
Okay.
It's not supposed to happen, really.
So,
repeat.
Yeah, thanks, Tips. So he asked, well, we don't explicitly ask for credit card information, but if somebody puts it in, are we obligated for PCI? I'm quite certain that by this time, somebody has posted their credit card information as a tweet, right? So that's stored somewhere. But I guarantee you Twitter's not PCI compliant because they have no need, they don't really store personal data. The issue is whether or not you're expecting to get cardholder data. Like if you're getting it and processing it, then yes, you're bound by PCI compliance. If somebody posts their Facebook status as their credit card number, what are you going to do? This is not a cardholder environment. You didn't know, you're not asking for it, and your little legal disclaimers at the bottom that you can say, well, our policy is we do not store credit card information, do not post them, things like that. Ask your lawyer for the exact wording, but the bottom line is if you're not asking for it and processing it, then you shouldn't be bound. And all the things I said today I like to think are very true and universal truths, but the reality is everybody's environment and applications are different. So if you have any specific questions for your environment, I encourage you to talk to a security professional like a QSA or somebody that's coming in and actually familiar with your systems, familiar with your application and what your goals are. Networks. So one of the things that, the themes that have been floating around for the last year or two is putting MySQL in the cloud or putting your data in the cloud. Which is kind of questionable. It's really hard to have a PCI environment in the cloud because you've got a tremendous amount of shared resources, and one of the things that people often overlook is you also have shared network. So by definition, your cloud network is an open public network. Not in that it's open to the public, but that it's shared with others, that you don't have control over. So there's a lot of white papers and a lot of companies who specifically address cloud security. And if you're thinking about putting your PCI environment in the cloud, think long and hard, read some of these white papers, ask questions of people who've done it before. There are solutions, I think you can get VPN within the cloud, so you can technically have encrypted communication for all your credit card information, but it makes it much more difficult. So I generally recommend that people maintain very, very strict control over your PCI environments if you choose to go the PCI route. Requirement number 5 says we must use and regularly update. Wow, this is actually much more readable on my screen, so I can't read it. So you can download the slides and read it. But use and regularly update antivirus software or programs. I think most of us know there's not a computer in the world powerful enough to run Norton antivirus and another software program. So, running it on your database server is pretty much a deal breaker. The wording in one of the subsections specifically says, and I'm going to read this, deploy antivirus software on all systems commonly affected by malicious software. antivirus systems on your gateway, on your mail servers, on your desktop. A Linux box running MySQL in a private network with a host-based firewall is not commonly affected by malicious software. So I'm going to totally ignore this in the context of MySQL, but as a larger PCI effort, it's certainly something you want to pay attention to. Requirement number 6 says we must develop and maintain secure systems and applications. Well, some of us have a role of not only the DBA but also the developers. So we also talk and work very closely with developers. So although not specifically related to MySQL, I think it's important that we at least cover this topic, touch on it so that we're familiar with it and can more intelligently work with our application developers. Next, we need to restrict access to cardholder data by business need to know. Very, very few people, if any, in your organization will need access to unencrypted credit card information. Those people that I can think of are those that need to do debugging and those that need to do dispute resolution and also those that want to commit credit card fraud. But other than those two, there's nobody else that needs it. So just be judicious in your grants and things like that and design your application around business processes and what you need. Assign a unique ID to each person with computer access. This just means no shared or anonymous accounts. It's very easy, it's a no-brainer, it's a best practice. Requirement number 9 says we need to restrict physical access to cardholder data, which means just at your data center you need to have swipe cards, biometrics, sign-ins, whatever. If you can have a locker on your cage, all the better. But this is not something that we can address in MySQL, so we're going to ignore it for now.
Can I ask you a question about something you mentioned earlier about access to the cardholder data?
Restrict access to cardholder data.
Right, you mentioned debugging there.
Right.
I mean, are you saying developers could have access to it at some point?
No, well, the developers shouldn't. I mean, well, A, your developers should not have access to your production systems.
That's my point.
And you can't use real live data in your test and development environments.
Right.
So generally what we do there, and this isn't exactly addressing your question. Oh, by the way, sorry, I didn't hear that. But he asked about developer access to cardholder data. Generally, as a DBA, you just want to write a script to generate fake credit card numbers and names. It really doesn't matter the contents because it's not like you select by them, right? Mm-hmm. And then you probably have a corporate account card that you use for all of your testing. So that will be probably the only real data in your account, but it won't be customer data, and that's the key differentiator.
Well, what do you mean with debugging then?
When I meant debugging, I'm more using that probably incorrectly, but for the business side, right? There are going to be, dispute resolutions. There's going to be, hey, my credit card doesn't work, which doesn't fit in the category of dispute resolution, but my credit card doesn't work. Great. So this is your credit card number. This is what we have, and somebody's going to have to, over the phone, okay, this is what your number is. This is what we have, or something like that. So business debugging. Sorry about that. That was unclear.
Well, it's been an issue for us to define that, because production support usually is done by developers, which you have overlapping roles of people who might get access to production data, but shouldn't. Sure,
and he said that sometimes the developers provide production support to the end users. And in a large organization, this is not a problem because there is a credit card team that I've never seen, and then there's the development team of which I'm a part. But when you have these crossover roles, you have to look at it in the context of what's being done. So the fundamental tenets of role-based access security are not by a person, it's by a role. So I can be the chief cook, bottle washer, security officer, and DBA. It all depends on the role I'm doing at that time. So first of all, you don't give your developers access to production environment. What you've done is you've given a customer service representative access to the production environment. So 9 hours a day he's a developer, but that 1 hour a day he's in a different role, and your business process requires that role be able to access the data in order to dispute or troubleshoot.
Right. The only problem with that is trying to convince PCI certification of the fact that you can actually effectively separate those roles. But then it comes down to semantics.
Right, yeah, and that's really hard because one person, I'm logged in, I'm a single person, I'm not a different role. He said it's hard to convince your it's hard to convince your auditor that you can actually separate those roles. Well, the best you can do is have them sign a policy paper, and the policy says when you're in this, you do this, when you're in that role, you do that, and try to enforce that as much as you can. But again, every environment is unique, and you need to have somebody who's familiar with your specific environment come in and take a look. Sometimes they won't accept, you can't separate that role. And the reality is what your auditor says is truth. I mean, that's, your auditor is God as far as you're concerned. So whatever they say, you have to abide by. But you can certainly make it easier for them to say, yes, that's okay, by providing supporting documentation and telling them how you're enforcing it. That's key. You know, whether it mean there's a separate phone in a separate room, and all that room is for is customer service. You know what I mean?
Yeah, I understand.
They're just looking for how you can, you know, enforce that and make it an unpleasant room so they don't actually sit there all day and code.
Thanks.
Requirement number 10 says we must track and monitor all access to network resources and cardholder data. That's a really, really tall order. In any real production environment, tracking access, tracking all queries for 5 minutes is going to give you gigs and gigs of data, and that's almost impossible to manage. So this is why we say the PCI environment needs to be as small as it possibly can and no smaller. Don't put everything in a PCI environment, because my Twitter username and password is not subject to the same security requirements as my credit card information, and it shouldn't be because it's much less valuable. In the keynote this week, they mentioned Oracle Audit Manager. So I guess there's some user interface that you can use for Oracle that now you can use for MySQL as well. I haven't played with that, but it's got a nice ring to it. It may or may not be relevant. And MySQL 5.5 has an audit plugin API, which looks very promising. So when 5.5 comes around, you're probably going to be able to use that to meet some of your requirements. But going back to the verbosity of logging everything, what you want to do is make your environment as small as possible. And my favorite example here is Amazon. Right? In Amazon, I can view my past purchases, I can view all these things, and none of that requires access to PCI. Even though it's got a dollar amount and a date and some other information, it doesn't have any cardholder data. This is all just, a primary key or foreign key reference to the data in my PCI environment. So odds are I'm viewing thousands or hundreds of pages before I actually make that purchase. The only time, and I'm going to use Amazon again, that it's going to touch the PCI environment is when I actually click pay. Right? Well, I guess Amazon's got a couple screens where it shows you the credit card, but it should be very, very low traffic. What you want to do is make it easier for your log administrators to consolidate that data by making it a low traffic environment.
Sorry to interrupt you again, but
yeah, no
how do you do the auditing now of the data?
What do you mean?
Well, you need an audit trail of who accessed the data.
Mm-hmm. I mean, MySQL, and we'll talk about this a little bit later, but there's a general logs Lowe query. So he asks how you keep track of who audited the data, or who looked at the data, who changed it, and whatnot. So MySQL offers this Lowe query log, general query log, and things like that, where you can track all access to cardholder data.
Right, but the general query log generally kills your performance. So.
Right, which goes back to making it a very low traffic environment. As awesome as you think your product is, you're going to get thousands more reads on your regular pages or browsing through your products than you are purchases. I'll use Amazon again. I will look at 1,000 books before I purchase one. I'll go through my recommended reading list, look at what my friends are reading, and then I'll make one purchase. So, and that's not true for all environments. So, let's talk a little bit about scaling, I guess, because that's what Percona is known for. But the traditional wisdom is that logging in any form is going to add a 3 to 5% overhead, 3 to 5% overhead for your performance, and it's going to saturate your I/O subsystem. So what you can do is you can break that across multiple MySQL servers. So, for example, I have a user ID, and then my credit card is associated with that user ID. Well, I can also have a user ID and then a credit card cluster ID. So my cluster ID is 5, which means I go to this instance of MySQL to retrieve the data. So you can break that up. But I've almost never find people that say, I'm getting too many credit cards. Like, this is where my bottleneck is.
Depends on your business.
Sure, I mean, yeah, it definitely does. And, if you're getting those, are you a level 1 merchant, level 2, are you in the millions?
No, it's not so much that, but we do debt collection stuff, so it's all related to credit card numbers.
Right, debt collection is a great example because you can get all of that information, except for the credit card number, out of a non-PCI environment, right?
But that's how we communicate with the people who give us that stuff. They give us those numbers to identify.
Right, they give you those numbers and then you load them. You can have some sort of ETL process to break that information up. And it's really, and I'll get to this later, but it's about what data you store together. So if you get that data import, break that up, put what needs to be secure in a PCI environment and what doesn't in a non-PCI environment. So, I don't know your business, but I imagine that, I've got to call this person and collect their money, right? 9 times out of 10, I don't need that credit card number, right? So only access it you absolutely have to. If you're accessing it all the time and you're accessing your PCI environment as your primary data source, that's going to cause you scaling problems. And it's particularly difficult to scale in a PCI environment. And one of the problems is like high availability solutions are typically fit-based, and you want to keep your PCI environment small. So what happens is you have routers in between your databases and your application servers, or your database application servers and your web servers. And those VIP solutions, the IP is going to be cached on these network hops in between, so your failover mechanisms aren't going to work very well. So failover in a PCI environment is particularly tough as well, which is again why you want to make it a non-high traffic environment. Yeah.
Actually, you mentioned about put in very small places, whatever, right? Is that how to guarantee those data in the database that nobody sees it and knows? How are you going to address those? Are you going to encrypt those, or is there anything you're going to cover later?
Well, so sure. Requirement number 3 is to protect stored cardholder data, and that means that we have to encrypt the data at rest. And they tell us what encryption is okay. But in terms of who accessed that data, we're going to rely on logging mechanisms from MySQL because you have to authenticate in order to select from the data. But there are other ways to access the data, such as via the file system directly. And that's going to be outside of MySQL. You're going to want any access logged, and we'll talk about this later, via the operating system. And so you're going to want to coordinate your MySQL logs, operating system logs, network logs, Apache logs, and everything in your PCI environment.
So is a MySQL have something like equivalent to Oracle and TDE, the transparent data encryption stuff, or are we actually talking about when you insert the data, is somebody has to...
Well, I'll cover that as well.
Okay.
But no, I'm going to use my favorite Peter Zaitsev quote. Oracle is like a BMW. MySQL, it's more like a bicycle. It can get you where it needs to go, but it might be hard getting there. So, a lot of these things that you Oracle DBAs take for granted just, aren't in MySQL yet. Requirement number 11 says we have to regularly test security systems and processes. Most of what we're going to talk about today can actually be scripted via Shell or Perl. And Daniel, one of the authors of MatKit, if you talk to him after, maybe you can talk him into MKPCI or something like that. That'll audit for you. But we're going to talk about that only in the context of data security rather than network security. And the final requirement is to maintain a policy that addresses information security for employers and contractors. If you're in a large organization, you're going to have no input on this. It's going to come down on high. You're going to sign it, and it'll come down from on high. You'll sign it and say, okay. If you're in a startup organization, you may have significant input into how this is generated and what it covers. PCI is very detailed about what it should cover, but most people aren't enterprise policy writers. So if you do a quick Google search for PCI policy templates or PCI policy examples, you can download or buy things that you can use them as a basis for your organization. So we're going to cover 9 out of the 12 policies. One important thing to note, again, is that even if you do everything we talk about today, you're not going to be PCI compliant. You'll probably not even have fully met all of the requirements that we will talk about. So it's holistic. There are a lot of other people that need to be involved at all levels of the organization. Any questions before I go on to the requirements in a little bit more detail? All right, so requirement number 2, as we talked about, is do not use vendor-supplied defaults for system passwords and other security parameters. You can download these off the internet. It's a no-brainer. I installed MySQL 5.1.40 something, and it gave me 5 default accounts. The interesting thing about MySQL is that all of the default accounts are local. In this case, test box 1 was the local box. It gives us 3 root accounts, 2 anonymous users, and 5 of them without passwords. MySQL knows that this is a bad practice, and they provide a script that will basically take us to achieve this requirement. It's MySQL secure installation. So first thing it says, do you want to set a root password? You say yes. PCI and other security frameworks go into great detail about password complexity length, how often things should be rotated, how far back in the password history can you repeat, things like that. There's no way to enforce this in MySQL. Right now, Those MySQL people have to rely on policies and punishments for non-policy adherence to make sure the passwords are changed and things like that. You can schedule a lot of these things via cron, but then your setup starts to get really complex, things go wrong, people get mad. The next thing it asks is if you want to remove anonymous users. Of course you want to say yes. There's no shared accounts in PCI, and anonymous users count as shared accounts. You want to disallow root login remotely, and although that's not a PCI requirement, it's just a really good idea. You only need one root account, and you never need to use it unless you're altering a table, adding a table, dropping a table, or creating a new user. And then it removes the test database and access to it. Most people think that this is not a security issue, but in fact, in some versions of MySQL, every user, no matter what grants you give them, if they have usage or above, have read and write access to the test database, which means I, as a malicious user who have a minimum grant, I can create a table, populate it, and fill up your file system. And if you think of security in terms of the CIA triad of confidentiality, integrity, and availability, that directly goes against availability because a malicious user with minimum grants can cause an outage for your application. It's not like you need test databases in your production environment anyway. If you do, you're doing something else fundamentally wrong. And then, yes?
Sorry to interrupt you again, but the discussion about downtime is not really relevant to the whole PCI thing, I think, right?
No.
we came up several times with an issue that might cause downtime, which the auditors brought up, and we go, well, yeah, fine if it goes down, but it doesn't expose your data.
Yeah, it needs to fail securely. When it fails, it can't just dump all credit cards to a text file somewhere.
Of course.
But no, there's no PCI requirement that says it has to be, highly available.
Right.
But it's a really bad idea to have something that goes down all the time. Availability is not addressed.
Right.
But in the greater security context, it is, because availability is part of security. So after I ran that script on my test instance, I'm left with root at localhost. With the 41-character password hash, MySQL implements its own SHA-based password hashing scheme. It supports two different password hashes. One is the one that I have above. The other one is old password, which is pre-4.1, which is a much less secure hash. People can write down your old password hash on a piece of paper and crack it manually. It's so bad. But just because you're using a more secure password hash doesn't mean you're actually secure. If I run strings on the user.myd file in the data directory in MySQL, I can get the user, the host from which they can connect, as well as the password hash. And if I copy and paste this password hash into passcracking.com, pass it to John the Ripper, or download Rainbow Crack, I can easily translate this into plain text. So I just want to reiterate, permissions for data directory, temp directory, and every other place that your data is being written should be locked down to the MySQL user specifically. As I said, PCI is not just the main requirements, but also sub-requirements and sub-requirements. Most of them don't apply to us, but 2.2.3 specifically does, and that's configure system security parameters to prevent misuse. This is really kind of vague and just looking for us to adhere to best practices, and I'll name a couple here, the ones that I think are the most important. Be judicious with your grants. If you use PHP MyAdmin, it's grant all on all privileges with grant option, I think by default. So nobody should have with grant option except for root at localhost. And one of the other grants that I want to call out today specifically is the super privilege. And the reason I want to call that out again relates to availability. MySQL has a max connections parameter that says you can have a maximum, let's say, 200 connections at any given time. But it also reserves one connection that only users with a super privilege can access. So if your application has super privilege, you can use those 200 main ones plus that extra one, which means the root can't log in and kill queries. So what would have effectively been a couple minutes of a blip in service can be an extended outage. And this is going back to the availability. Your application user probably only ever needs select, insert, update, and delete. If you need more than that, you're probably doing something wrong. If you want to disable local in-file, I won't go into the details. You can go on mysql.com and read about it for yourself. Disable old passwords, which is the old insecure password hash. Set read-only to on in your replication slaves. Again, one of those things that people don't think about in terms of security, but what read-only does says, oh, if you don't have a super privilege, you can't write to the database. And this goes directly to our, back to the CIA triad of integrity. If you don't have this on the slaves, there's basically no guarantee that your master and slave are going to have in-sync data because somebody can change the data on the slave. And then enabling secure authentication, which again has to do with refusing the pre-4-1 password hashes in MySQL. It's a little redundant with disabling old passwords, but you can really, if there's a bug in old passwords, then you're at least protected twice. Requirement number 3 says that we must protect stored cardholder data. They go into detail about what encryption you can use, and they actually enumerate what they consider to be cardholder data. Of the 7 elements that they consider, only 4 are storable. The primary account number, cardholder name, service code, and expiration date. And if you do store those, protection is required. But only requirement 3.4, which is you must obfuscate the data on disk, needs to be enforced on the primary account number. But it's considered a best practice to go ahead and consider all of this applicable for 3.4 because it's really easy to do. If you're going to do one, do it all. You're never going to do a where clause on a credit card number, right? So there's no point in having it searchable in plain text. But the data that you explicitly cannot store is full magnetic stripe data, CVV2, and the PIN. Right? But even though you're allowed to store those 4, doesn't mean you absolutely have to. You want to keep your PCI environment as small as possible. It just makes your life generally easier. MySQL has an official page where they list encryption functions, and normally I wouldn't do that. I wouldn't read them here, but I think it's such a bad page that I really need to walk through it. There are 4 methods that have bidirectional capabilities, i.e. I can encrypt data and then read it back, and then there are a few one-way hash functions. The encrypt functions begin with AES encrypt and decrypt. This uses a 128-bit encryption AES algorithm. It's widely regarded as the most secure password function or encryption function in MySQL. You can actually go in and change this to 256-bit encryption by editing, I think it's include AES.h and recompiling yourself. But unless you have a very, very compelling reason for doing that, don't. I've seen people recompile it, poorly with debugging enabled, incorrectly, and you lose all of the optimizations that the MySQL team worked so hard to give you in their compile flags, and you make upgrading a nightmare, right? Because then you have to do this for every single version and test much more thoroughly. So again, unless you have a very compelling reason, don't. Compress and uncompress, they're listed as encryption functions. It makes me sad. Don't use them. They're not encryption functions. They're not PCI compliant. Same thing with encode and decode. The other option that we have that will fit PCI is desencrypt and decrypt, but it's not quite as secure as AES, so we'll use AES in our examples here.
Are we required to use those in the database, or is there a way to get around that, say, by encrypting in the application middle layer and take whatever encryption we want to have?
Right, he asks if we can, if we have to encrypt in the database or if we can do it in the application layer. I'll talk about that later, but I might as well say it now. Encrypting via these functions in the database is probably not the best way to go. The best way to go is probably going to be to do it in your application layer because you have a greater amount of library support, like 128-bit AES is, for a large government organization, not secure at all. But they say it's secure enough for credit cards. PHP has a ton of libraries that give you much more flexibility and things like that. So my general recommendation is to, yes, encrypt it in the application layer and do that. There are a variety of other advantages as well. But requirement number 3 would be a day-long talk. Right? How to do this correctly, what your options are. There are just too many to talk about. I really wanted to limit it to MySQL because online I see a really poor understanding of the encryption functions and how they function with the MySQL. So yeah, absolutely. I mean, if you're going to do it in the application layer. That's generally better. Then we have one-way functions. Encrypt, which uses Unix crypt, MD5, which is subject to collisions, SHA and SHA-1. Someday we'll get SHA-256, and then old password and password is pretty self-explanatory. So using some of the data that we're allowed to store, I created a sample table. It's just got auto-increment primary key, credit card number, service code, and name on card. You'll notice that all of the data here is var binary, and that none of it matches the length that you'll expect. So an encryption of some data is not a one-to-one translation. So if I encrypt a 16-digit credit card number, I actually have to put it through that formula, 16 times 16 over 16 plus 1, which gives us 32 characters. So an AES encrypted 16-digit credit card number is 32 characters. Service code is either 3 or 4 characters, and the name on the card is 32 characters. Interestingly enough, unlike the car functions, if I store 15, or the car data type, if I store 15 characters in a car, I can still read it. If I store 15 characters in a var binary, 16, I can't do it. I'm going to get back a null, so I have to use var binary. So in order to insert, we're going to use the AES encrypt functions, which take two parameters. One is the actual data that you want to encrypt, and the other is a secret key. I've used a horrible secret key here, don't use this. But some best practices with key management, because you can see this in show process list and other places. Never commit it to disk anywhere. Use a variable if you can. Best practice is when your application starts up, make it an interactive startup, and have somebody manually enter this secret password. So it's never committed to disk, and you can only have it in memory. There are a lot of tools out now where I can dump the contents of running memory without affecting the performance of the host, but it's still it's a much more technical hack than a show process list. Things like that. If we just do a raw select from the table, we'll get garbled data, and this is how we can tell that we've successfully encrypted it. So we're going to need to use the AES decrypt function, which takes two parameters, the column that you want to select and the key that you're going to use. If you use the incorrect key, you won't get the gibberish that we just saw. What you'll get is a null value. So one way to tell that you're using the correct key is just if you don't get null. This has somewhat of a performance impact. As you know, don't index anything that's encrypted, because you're not going to be able to use that index anyway, because you've got the column wrapped in a function. We haven't quite met the threshold for securing customer data, because if you're using MySQL replication, all of these things are going to get written to the binary log. So you can see I just ran MySQL bin log, and we can see the unencrypted credit card numbers, and encrypting in your application is actually going to get you by this. You're never going to see it, you're only going to see encrypted data. So statement-based replication will not work in a PCI environment. There's no mechanism in MySQL that you can obfuscate the data before it's written to disk. 5.1 and above has row-based replication, which instead of sending a statement to the slave, sends the binary change log. So it effectively sends the encrypted data. We've got the block, and then we've got effectively what it is if we translate it into SQL, and notice that it's encrypted data that you're going to insert. So row-based replication is one way to get around that. There's also the general query log, slow query log, and we need to make sure that either those are disabled, or if we're going to write them to disk, it's on an encrypted partition. And that's the only way that we can ensure that all of the log data is secure. Yes?
As part of the requirement to track and monitor your encryption system, how can you disable the general log?
How can you disable the general log?
That's what you would use to monitor what's being inserted into the database.
Right, you can in 5.1 you can put the slow query log to 0.0 seconds, so it tracks everything.
What I'm saying is the PCI auditors require that it's monitored.
Right, then you write it to an encrypted partition, right? But you don't have to have the slow query log and the general log, right? That's twice the writes. But yeah, you're right. For the logging, you do need to have one of them, and when you do, either make sure that the data is already encrypted before it hits the log, or put it on full disk encryption. Now,
for your full disk encryption, I mean, like Linux encrypted file system, would that count as it?
I'm not familiar with Linux encrypted file system. I've used a lot of third-party products. Bottom line with full disk encryption is what I've seen, it's expensive, buggy, a performance killer, or some combination thereof. Do yourself a favor, if you're looking at full disk encryption, run a load test and pull out the plug. If you can boot the system, mount the partition and read the data, I'll buy you a beer. It's just so hard to do right. But if we have an encrypted, so that for your data directory, that might be a deal breaker. But for your log directory, it's probably not, right? If you lose some logs, like we have a policy for that, just address what can happen there. But yeah, so for your data directory, it might be a deal breaker. And we can also encrypt in the application layer. That has sort of its own pitfalls and difficulties, but it's generally a much more flexible solution. All of the data is encrypted before it hits MySQL, so you don't have to worry about any of this. So your general logs, fine, turn them on, put them unencrypted. It doesn't matter because the data that is required to be encrypted is encrypted. Some of the other requirements in number 3 is to keep cardholder data storage to a minimum. We talked about that, you want to do that anyway. don't store sensitive data, and mask the primary account number when it's displayed. They actually let you display this, the first 6 and the last 4 digits. So in your 15-digit Amex, that's 10 of 15 characters. That's just rude. Like if you went to Amazon and it showed the first 6 and the last 4, come on. So the industry standard is just to show the last 4 and then a bunch of stars before it. Do that and it'll make your users happier, even though you'll still be PCI compliant. And don't forget your backups. If you're not encrypting in the application or encrypted file system and you back up, make sure that you're not backing up actual cardholder data. If you do, make sure it's encrypted cardholder data or encrypt the entire backup if you can't find a way to do that. Yeah.
Just store the last 4 digits.
No, you're allowed to display. Requirement 4, encrypt the transmission of cardholder data across open public networks. We talked about remote data centers. You want either to use, make sure that the network traffic is encrypted, such as using a secure VPN, or make sure that the data is encrypted before it's played to the other data center, and you can do that via application encryption or row-based replication, or you can use MySQL replication over SSL. There are a lot of tutorials on that. Apparently it's a very difficult thing to set up. I've never had a problem setting it up, but some people do. But the funny thing is I get these calls. Ryan, oh my God, replication is down in my PCI environment. I say, oh, are you replicating over SSL? I say, yeah. I say, oh, did you do that a year ago? Did you put it in place? I say, yeah, right. I say, oh, your certificate's expired. Right? MySQL doesn't tell you why it broke, and nobody can figure it out unless you're really familiar with how SSL works. So if you're going to do a replication over SSL, there are a lot of pitfalls. Make sure you monitor things correctly so you get an Agios alert a week before you're about to expire so that you can handle that accordingly. I had one customer a long time ago who had a secure environment, with all the credit card information, a bunch of other data that was subject to various laws, and then they replicated out of the secure environment into an insecure environment. Which is okay because they said they didn't replicate those databases. The interesting thing was they had it configured on the slave just to not play those aspects of the relay log. So those statements were all being executed, or all being replicated to that remote host in an insecure environment, and they were sitting in the relay log for anybody to look at. They were just filtering on the client side. So keep your PCI environment simple, right? Keep everything self-contained. Don't try to replicate and do anything fancy outside, from a secure environment to an insecure environment, things like that. It'll just make your life miserable. Requirement number 6 is we must develop and maintain secure systems and applications. It means we need to keep applications up to date, things like that. Specifically, I'll just read through this. You have to validate all input, proper error handling, validate cryptographic storage and secure communications, separate your developed, test, and production environments, copying data when you're loading data into the dev environment so that your developers can write against real data. You want to just make sure that you fake the credit card data. You should never have any real information. You also need, if you're an application developer as well as a DBA, protect against things like SQL injection, cross-site scripting, cross-site request forgery, and things like that. Specifically, as it applies to MySQL DBAs, we need to establish a process to identify newly discovered security vulnerabilities. It doesn't say it needs to be an automated process or a great process, it just needs to be a process. And you can cover this with a subscription to BugTrack and the MySQL announce list. Go through those, read them if they apply to your environment, read them more deeply and investigate, and if it's something that affects you in terms of security, come up with a plan to either upgrade or mitigate that problem. And it doesn't say you have to upgrade within X number of days. It says write a policy for it and follow that policy. So some people say, well, if it's a minor bug, minor security issue, we have 60 days. If it's medium, 30, and if it's critical, we have a week. So just write a policy and follow it. And then 6.4 says we have to follow change control procedures for all changes to system components. Developers do this. Developers have done this forever. Somehow, DBAs never got into this habit. What you need to do is use Subversion or some other issue tracking system, or excuse me, revision control system. Documentation of what what's the impact of your change. You need management sign-off, which is a great CYA. You need to test its operational functionality. And most important, and this is where everybody rolls their eyes, is back-out procedures. People say, oh, we're dropping a column, we can't back out. I say, sure you can. Say restore from backup. It's not a great procedure, but it's a documented and functional procedure, right? So, if you're going to do something that you basically can't roll back from, take a backup before, do your change, you've got to roll back, restore from the backup. Now, hopefully you don't actually have to execute the rollback procedure, but you have to have it documented. Requirement number 7, restrict access to cardholder data by business need to know. Again, very few people in your organization will need to see the raw data. Views are your friend, use them. Grant permissions around the views and what people need to see. And then follow account best practices. We talked about most of them in requirement number 2. It's very easy. MySQL offers some resource limits that we can use that can be interesting. Queries per hour, updates per hour, connections per hour, and things like that. These aren't particularly great in most contexts. What I'd really like to see is this user can only do this much during these hours, and the rest of the hours they can't log in or whatnot. So some environments that need that, what I've seen is external cron jobs that 8 a.m. adds the user, 5 p.m. deletes the user. But invariably what happens there is the person comes in early or leaves late, can't do their job, everybody gets angry. So there are pitfalls associated with that, but if you really need it, you can. Requirement number 8. It says we have to assign a unique ID to each person with computer access. We talked about this, no anonymous accounts, no shared accounts. It's not much more to it than that. Number 10, here's where we get into the logging. Yeah, there's a lot of things that we have to log, but I don't think this is particularly useful because you can go read it on, go download the requirements and read them for yourself. What I think is more interesting is the SANS FBI released a top 5 consolidated log reports that you should be looking at on a daily basis. And the number 1 is attempt to gain access through existing accounts. So people who have valid accounts but are trying to do something that their role should prevent them from doing. Number 2 is a failed file or resource access attempts. So again, people trying to get to things that they can't, but this is different from number 1 in that it's not specifically valid accounts. Number 3 is unauthorized changes to users, groups, and services. In the context of MySQL, you can pretty much just check something in your MySQL database, and if it changes, the users table and permissions table, if it changes, send an alert via Nagios. I mean, you really shouldn't be changing permissions that much, so anytime you get an alert or see a change, you should be very scared. Number 4 is systems most vulnerable to attack. Right? The box that's not plugged into the network that's sitting in the corner is probably not most vulnerable to attack. Boxes on your internal network with no publicly facing addresses are a little more subject to attack, but not nearly as much as your web servers or application servers or anything that's publicly facing. And then any suspicious or unauthorized network traffic patterns. So if somebody's logged in at work and sitting at their desk, any other remote login for them should be looked at, investigated as a malicious attack, or anything that's off business hours, that people don't usually work. Requirement number 11 says that we must regularly test systems and processes. Well, a lot of things we've talked about, you put in a shell script or a Perl script and just automate it, and you should run those every couple of days or every week. If you've got a security guy within your organization, make sure they're regularly penetration testing your application, and make sure that you're prepared for your quarterly audit. Because the quarterly audit basically goes like this. You give somebody a lot of money, they do their audit. Ideally, that's where it stops. But if you don't regularly test, you give them a lot of money, they do their audit. You give them a lot of money, they tell you what to fix. You give them a lot of money, they come back and tell you you're okay. I mean, it's very, very expensive to do this if you don't do it right. So it's much cheaper if you just, everything's ready for you, come in, look at it, 10 minutes later, well, you're done. Requirement number 12, again, this addresses just information security policies for everybody in the organization. Probably going to come from top down, but if it doesn't, chime in, make your voice heard. Look at some of the examples that you see online. There are actually 9 things that specifically they say have to be addressed. So look at those. I won't read them here. So we've actually got a couple minutes. We've got 5 minutes. If you have questions, I can take questions, or I can go over some of these top 10 minutes.
About PCI and MySQL, what do you think about products like Pack General and others? I don't know which others, but do you know Pack General?
Well, there are a whole bunch of, what about these security appliances and products and things like that. And this goes to myth number 1, actually. One vendor and product will make us compliant. And I'm sure if you've read the literature for them, they probably have a how we address PCI checklist.
They address a bunch of PCI points, but not all of them.
Right, yeah. But the thing is that they'll say, we address requirement number 5, which is antivirus. well, they address requirement number 5 for that specific place in the network in which they sit, but not the mail server, not the gateway, not the desktops and things like that. So you got to be very careful because here I can check off 9 that we talked about, but in reality we talked about a very small subset of some of the sub-requirements of the 9. There are a lot of really good products out there, some specifically designed for PCI compliance, and they do a lot better job of, they can translate your information security policy into a codified set of rules that can then enforce that for you to some extent. So you can get appliances that are going to save you a lot of time, but the better the appliance, the more the money.
Well, I'm talking about this appliance that does MySQL only. I'm not talking about
okay.
other things, just MySQL. That's what I'm talking about back in general.
I haven't seen that appliance.
Well, they do. The new version is an appliance. Has MySQL server in it. It's hardened. Root can have access to MySQL files, and everything is logged. Blah 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 blah. Just like PCI, just like PCI is.
Sure. MySQL, your database is a very small portion of PCI compliance. So if you get that and it makes these things that we've talked about complete, that's great, but you still have a long way to go. So if you have a lot of MySQL expertise within your organization, then you can accomplish what we talked about fairly easily, right? They'll do a lot more, they'll do it directly, and they'll probably work with other vendors to be able to enforce things that, your policies and things like that. And they probably actually have that built-in password complexity and a lot of other features that we won't get. But again, MySQL is a really small part of your PCI environment. So it's probably not going to save you that much money.
Well, the name of this conference is MySQL and PCI.
Sure.
So, all right. Well, okay, so do you know of any other products that do?
That are just for MySQL? No.
Not just for MySQL.
No.
Oh yeah, you were talking about the general log, binary log, and slow query log. It occurred to me that queries show up in the error log too. The error log is not just for
Right, that was the etc.
Oh, okay. So,
But yeah, the error log as well. And most of the queries that are going to show up in the error log are the queries not safe for statement-based replication and things like that.
Yeah, but I've seen even strange stuff. Some people do like some monitoring things show up in the error log. I come across this because work on MK error log.
Yeah.
I deal with a bunch of error logs and see a lot of bizarre things in there. But some are not even that closely related.
Yeah, and so anytime that MySQL is going to write to disk in a logging fashion, you're going to want to make sure that the data is encrypted before it hits MySQL, so that it's only writing encrypted information or stored on an encrypted partition. All right. Well, thank you very much. Oh, sorry.
I was going to say, in the interest of free beer, if anyone needs a how-to on how to use Lux in an encrypted partition and use it for either logging or the entire MySQL partition, see me afterwards. I'm glad to give you a card. I'll write up on that.
Yeah, definitely. I mean, there are a whole lot of full disk encryption products. Some are better than others, but I found that the really good ones are also very expensive. And that may not be the case. I'm not familiar with all of them. There are just a whole bunch. But yeah, test it. I mean, it can make your life easier. Then you don't have to do all this encryption that you would have had to before. And especially if the performance is there as well, then your cardholder requirement can scale much more easily. Yeah, definitely. All right. Thank you very much, everyone.